Hello everyone. This tutorial is about multiplication and division word problems. We are going to look at our GET strategy. Hopefully your child has come home and told you about that already. We will look at how to multiply two digits and one digit number together. We will look at several division strategies. And finally, some multi-step problems examples. Let's begin. GET strategy. It is called GET because it stands for group, each, and total. GET. Here's an example. Farmer John has 3 boxes. If he put 15 apples in each box, how many apples does he have in all? Let me think. 3 boxes. I think that is an important information, so let me circle it. If he put 15 apples in each box, 15 apples seems to be an important information as well. I already have my important information that needs to be circled. Now let me look at the actual question. How many apples does he have in all? Let me underline the key words that are important and that will help me understand if I'm going to multiply or divide. It said how many apples in all. So I am looking for how many in total. That means I don't have a total yet. You have 3 boxes. Boxes hold the apples because group are always the holder. It hold the items. So 3 boxes would be the group. So I'm going to put a G here. If you put 15 apples in each box, it's set right here, each. So 15 is your E. So let me put 15 here. And we're looking for the total. So I put a T at the end. So for each word problems, I expect our students to circle important information, underline keywords in the question, and identify their GET. The reason why we're doing this because when we mix in division problem, if they have a total already, that means they are going to divide. If they are looking for the total, then they need to multiply. So we'll always go back to the had a total and need a total strategy, had and net. So the question is 3 times 15. Let's see how we can solve it using different methods of 2 digits times 1 digit's number. So the problem is 15 times 3 or 3 times 15. For the base 10 or pictorial model, I'm going to draw 15 like this. 1, 2, 3, 4, 5. And I have 3 groups of 15. And here's the third group. 1, 2, 3, 4, 5. Again, I have 1 group of 15, 2 groups of 15, 3 groups of 15. These lines represents 10, and these dots represent ones. Students have been using this pictorial model since 1st grade. Now we can look at partial products. So I usually have students write the 2 digits number on top and the 1 digit number at the bottom. This nosy neighbor 3 likes to go into everyone's business. Nosy neighbor goes to the ones place, 5 times 3. Let me look at my ones place. I have 3 groups of 5. So 3 times 5, that equals to 15. Let me put 15 here first. I have part of my product. Then nosy neighbor also goes to the tens place to visit 1. Let me look at my tens place. I have 1, 2, 3 groups, but I don't have 3 groups of 1. I actually have 3 groups of 10s. So 3 times 10 equals 30. In order to find my total, I need to add up these 2 numbers together, 15 plus 30. And using the pictorial model is 15 right here in the ones place and 30 in the tens place. So 30 plus 15. And that's how I know my answer is 45. 45 apples in all. Eventually, I would like our students to use our regrouping model or the standard algorithm. 15 times 3. Again, nosy neighbor goes into the ones place. 5 times 3 equals 15. I know I have 15 ones. However, I cannot put 2 digits in the ones place. And since I can make a 10, I'm going to do that. Make a 10 and bring it over to the tens place, and oh, sorry about that. Here we go. And I regroup it. So now I have 5 ones left. I'm going to put a 5 here. The one supposed to be here, I already regrouped it, and I move it to the tens place. So I'm going to put +1 on top of the tens place to remind myself that later on I need to add it back. Now the nosy neighbor goes to the tens place. Once again, 3 times 1 equals 3 because I have 3 groups of tens. This is actually a 10, but it's already in the tens place. 3 times 1 is 3, plus the 1 that I added, and that's how I know it's 4. So that's the standard algorithm. Once again, the answer is 45 apples. Let me see if the answer is correct and if it makes sense. I have 3 groups, okay? 1, 2, 3, and each group has 15 apples. Together, if I add up these 3 numbers together, the answer will be 45. That makes sense, so I know my answer is correct. If I did not multiply it, if I divide it instead, I do 15 divided by 3, and I know the answer is 5. Let me see if it fits the question. The question said how many apples in all, and if I say Farmer John only has 5 apples in all, it would not make sense, so I know this is not a division problem. So after students complete a question, we also want them to look back at the keywords that they answer to see if it makes sense. Now let's look at the division problem. Farmer John has 15 apples. If he put 5 apples in each box, how many boxes does he need? Let me think. He has 15 apples. That's important. Let me circle my information. If he put 5 apples in each box, so the each is 5 apples because it says right here. Let me put the 5 here already. That's my each. But is 15 my group or my total? Well, 15 apples cannot hold 5 apples. That doesn't make sense. And he cannot have more than 15 apples. The question say how many boxes. I know boxes hold apples. Once again, the group is your holder. So I know I don't have my group right now. And in other words, 15 apples would be my total. I'm looking for my group. So 15 is my total. Well, because I already had a total, that's a heads problem. That means I'm going to divide. Now for division strategy, we will go over a few different ones, but they pretty much means the same thing. In this case, I would one of them is called the spaceship strategy. Students seems to remember that more because it's kind of fun. So we put 15 in the middle of all the spaceship. So we don't know how many groups, but we know we're putting 5 in each group. So we're going to do 1, 2, 3, 4, 5 in one group. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, I am done. I finished all my 15. So this is called a spaceship because you have all these little circles sticking out. And 1, 2, 3, that means I have 3 groups. 3 times 5 equals 15. I know that is the correct answer. Another strategy students can use to divide is using our array. Because there are 5 in each group, I can just simply draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I am done. I have a total of 15. And let me see how many groups I have. I have 1, 2, 3 groups. That tells me my group is 3 and have 5 in each group with a total of 15. So let me see. The question is how many boxes? And if I say there are 3 boxes and 5 apples in each box, that will give me a total of 15 apples. That sounds about right. If I multiply it, wow, that will be a lot of boxes. That would not make sense because it said he only put 5 apples in each box. And therefore I know 3 is my correct answer. Not 15, it's 3 because we're looking for the group. And of course, eventually we would like our students to write 15 divided by 3 by 5 equals 3 boxes. That would be our answer. Finally, I'm not going to go over how to solve these problems. I just want to show you a couple of examples of how these multi-step problems will look like. Here's example 1. Tennis balls are packed 3 to a can. Sally bought 4 cans to use at her tennis lessons. Her friend bought 5 cans. How many tennis balls did Sally and her friend buy altogether? So students will need to do 3 times 4. Then they need to do 3 times 5 and add up the two numbers together. For the second example, Roman makes 36 muffins for sale. He puts 6 muffins into each box and sells the boxes for $5 each. If he sells all the boxes, how much money does Roman make? So in this problem, students will need to do 36 divided by 6 and then multiply by 5 each. I hope this video helped you understand a little more about what we do with our multiplication and division word problems. Thank you.